Hey kids, Flexing Teacher Weber here. Hope you're having a good day. Today we're going to start looking at calculating the area of a circle, or the number of square units that will cover a circle. Now we've already been working on calculating the circumference. Circumference is the distance around the circle. The area is the number of squares that cover the circle. Now before we start doing any area calculations today, we're going to have to look at something called exponents, because exponents are a major part of the area of a circle calculation. So today's lesson is just going to focus mainly on exponents and what they are and how to use them. So, let's look at this chart I made. I said to find the area of a circle, you have to know about exponents. So what I've got here is I got a bunch of repeated multiplications, everything from 1 times 1 to 8 times 8. All right? Now, the way you write a number in exponential form is it's a shorter way of writing the number. It's often used for numbers that are very, very, very large, but it can be used for smaller numbers as well. So let's take a look at this chart. I've got the repeated multiplication 1 times 1. The way I would write that in exponential form is I would write a 1, and I would put a little 2 in the top right-hand corner. That little 2 is an exponent, and that little 2 means that I write down the 1 2 times and multiply them. And then in standard form, we know that 1 times 1 is 1. So if I had 2 times 2, I would write that as 2 with a little 2 in the top right-hand corner because there are 2 of them. And we know that 2 times 2 is 4. And continuing with the chart, if I had 3 times 3, I would write a 3 with a little 2 in the right-hand corner because there are 2 of them. And 3 times 3 is equal to 9. And if I had 4 times 4, I would write 4 with a little exponent 2 in the top right-hand corner. And we know that 4 times 4 is 16. And if I had 5 times 5, I would write a 5 with a little 2 in the right-hand corner, and 5 times 5 is 25. And moving right along, if I had 6 times 6, that would be 6 with a little 2 in the right-hand corner, and 6 times 6 is 36. And if I had 7 times 7, you probably see where this is going. That's 7 with a little exponent 2 in the top right-hand corner. And 7 times 7 is 49. And if I had 8 times 8, that would be 8 with a little 2 in the top right-hand corner. And 8 times 8 is 64. Now, all of these exponents that we just looked at are all with an exponent 2. But we can have other kinds of exponents as well, and there's also some parts of an exponent that we need to look at. So on the next slide, we're just going to break down some of these exponents a little bit more. So there are 3 parts to an exponent. There's a power, there's a base, and there's the exponent part. Now, 5 with exponent 2. The power is the whole, both parts of the number together. So for this particular situation, if I have this question right here, the power is called 5 to the power of 2. We say 5 to the power of 2. Or we can say 5 squared, and I'll talk more about that in a moment. The base of this number is the big 5. And the exponent part is the little 2. Now we read this number as 5 to the power of 2, or we can read it as 5 squared. Now why can we say 5 squared? Because what this number represents, I'm just going to go over to the side over here, what this number really represents is this number represents a square that has side lengths of 5. And we know from our previous section that if a square has side lengths of 5, then its area must be 25 square units. So that's why we can call this number, we can say 5 squared, because it literally makes a square. So we read this number as either 5 to the power of 2 or 5 squared. Now, let's look at another one. This number here, a 2 with an exponent 3, we haven't seen one like this yet. Well, the power would be 2 and the exponent 3, and we would read that as 2 to the power of 3 or 2 cubed. And I'll talk more about that in a moment. The base of this number would be the large 2, and the exponent part would be the little 3. Now we read this number, when we say 2 to the power of 3, or we say 2 cubed. Now the reason we can say 2 cubed is because this would form a cube with side lengths of 2, so it would look something like this. On the spot, going to draw a cube here. This isn't the best cube, but you'll get the idea. So this forms a cube with side lengths of 2. And 2 to the power of 3 actually means 2 times 2 times 2. It means writing the 2 down 3 times and multiplying it together. And that would give you an answer of 8. By the way, this is the world's worst cube ever. Tough for me to draw it on my iPad, but that should be a cube all equal sides. All right, so 3 parts to a number that has an exponent in it. The whole thing is called the power. The large number is called the base, and the small number in the right-hand corner is called the exponent. Now let's break these apart even further. This question says, write each exponent as repeated multiplication and standard form. Okay, 4 to the power of 3. As repeated multiplication, that means 4 times 4 times 4. Not adding them, multiplying them. Now 4 times 4 is 16, and 16 times 4 is 64. So the answer to this question would be 64. That's the standard form. The repeated multiplication for 3 to the power of 4 means I write down a 3 4 times, and I multiply them all together, right? The base is 3, and the exponent tells me to write that 3 down 4 times. And when I multiply that together, remember I'm not adding them, I'm multiplying them. 3 times 3 is 9, 3 times 3 is 9, and 9 times 9 is 81. So in standard form, this answer is 81. Now another question, 9 to the power of 1. This means to take the 9 and write it down once. And that's all you can do. That's your answer. 9 to the power of 1 is just 9. You write down a 9 once. Let's look at a couple others. Okay, 2 to the power of 5. This means take a 2 and write it down 5 times. And multiply those 5 2's together. Okay, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So in standard form, this answer is 32. Now the last one, 1 to the power of 7. This means take a 1 and write it down 7 times. Multiply those 7 1's together. And when you multiply 1 times 1 times 1 times 1 times 1 times 1 times 1, you get the standard form of 1. In fact, 1 to the power of anything is always going to be 1. So in these 5 questions, we were writing them first as repeated multiplication, and then we were writing in standard form. Just another note as well, sometimes you'll be asked to evaluate answers. Writing in standard form is the same as what's called evaluating. When you're asked to evaluate, it means to find in standard form. Okay, last question I want to do. I'm going to flip forward. This says write these numbers as powers of 10. So that means I want to write them as multiplications using 10. Well, number 1, to write 10 as a power of 10, I want to write it as a base of 10. So that means my base will be 10. And since I have only one 10 there, the exponent part on that would be 1. So as a power of 10, the number 10 is 10 to the power of 1. Now if I apply that same idea to number 2, okay, if I can break down 100 into tens using multiplication, it would be 10 times 10. And that would be 10, since there are 2 of them, to the power of 2. Now let's use the same idea in number 3. I can write 1,000 as 10 times 10 times 10. And look at the mental math here. All I'm doing is writing a 1, and since I have 3 zeros, that makes 1,000. Now, if I'm writing this as a power or an exponent, that's going to be equal to 10, and since I have 3 tens there, to the power of 3. Using this same idea with 10,000. Well, 10,000, since there's 4 zeros there, I could write it as 10 times 10 times 10 times 10. 1 times 1 times 1 times 1 is 1, and then tack on 4 zeros, and that's 10,000. As an exponent, that would be 10, and since there are 4 tens there, to the power of 4. Okay, I hope you're getting the pattern here. The next one, 100,000. 10 times 10 times 10 times 10 times 10. There are 5 tens there, so that would be 10 to the power of 5. And then the last one, 1 million. Well, there's 6 zeros on 1 million, so check out the pattern. 10 times 10 times 10 times 10 times 10 times 10. 6 tens there. So if I'm writing this as a power of 10, that would be 10 to the power of 6. And notice, exponent 6, 6 zeros on 1 million. Exponent 5, 5 zeros on 100,000. And you can see writing these numbers as powers of 10 is a much shorter way of writing them, especially when we get into really large numbers, like really large numbers, or the opposite end, really, really small numbers. It's often easier to write them as exponents. And writing numbers as a power of 10 is a very common thing that we often do. So today's assignment is just going to focus on powers and exponents. Make sure you refer back to this video when doing the assignment. Flexing Teacher Weber, out.